For ZDNET, I'm Dan Patterson, and today's interview is with Ilke Demir. She is a senior research scientist at Intel, and her team has developed a real-time deepfake detection mechanism that doesn't just look at computer artifacts, but instead examines biological components, the stuff that makes us human. In just a few short years, deepfakes have gone from being a novelty, kind of this computationally heavy process, to being everywhere. And of course, they can be used for all sorts of nefarious purposes, for hacking, for misinformation, and tons of other stuff. Ilke has spent a lot of time examining AI ethics, and she and her team really invest the time and energy to make sure that the AI systems they're developing now are as free of bias as possible. She spent a ton of time talking about this, and she has some real thoughts about where we are headed with generative AI and the path to artificial general intelligence. Just a few years ago, deepfakes seemed pretty novel, and they required fairly serious computing resources to create. Today, of course, deepfakes are everywhere. They seem ubiquitous. For ZDNet, I'm Dan Patterson with Ilke Demir. She is the senior staff research scientist at Intel Labs, and she has been working on Intel's newly created real-time deepfake detection technology. So, Ilke, thank you very much for your time today. Let's before we kind of dive into the deep end of serious AI, let's kind of lay a foundation. What are deepfakes, and how does artificial intelligence help them scale beyond just this kind of novel technology?
Right. So deepfakes are videos, speech, images where the actor or the action of the actor is not real. So you may see, the audience may see you like that, see me like that, but are we real, or are we really realistic and created by AI? So the reason that it is called deep fake is that there's this complicated deep learning architectures, generative AI you may call, behind creating all that content. And it's a little bit more realistic and further from the samples that are being used to create those synthetic media than the traditional slowing down or splicing or cut paste, etc.
Yeah, so I'm glad you drew that distinction. We have seen deepfakes that are fairly crude and just do exactly what you described. They kind of slow down or speed up or alter video that already exists. But what you are describing is synthetic personalities created through artificial intelligence. Can you tell me how that technology works?
Right. There are several ways that deepfakes are using. So one of them, and the most general one, is generative adversarial networks, GANs for short. Those GANs are actually the foundation, one of the foundations for generative models, and it's actually two networks trying to play a game. So one network is trying to create as much realistic content as possible, and the other network is trying to guess whether it is a real one or a fake one based on the real samples that we feed to that. So these generative adversarial networks are trying to mimic the data distribution of the real samples. So whatever real images or real videos that you give to a generative adversarial network, they are trying to mimic that data manifold to sample more samples from that distribution. GANs are not the only one. There's also variation autoencoders or autoregressive models that are creating images that are taking the expressions or mimics or gestures from one face, applying it to another face. There are face swap technologies, which is one of the other famous ones. There are lip sync technologies that are keeping the face but only making the mouth say other things based on speech or based on voice or based on a combination of both. And nowadays, we are also seeing those diffusion models, which is the latest and brightest in generative models that are creating all these text to X models, where they start with natural language embedding, so a knowledge about all the words and all possible things that we can create. And then with that text prompt, they sample from the text distribution and have a correspondent like clip representation for that text distribution to convert it into image, convert it into a video, convert it into a 3D object, convert it into a 3D video, and all of those text to X models are evolving right now. So that is a summary of current generative algorithms that can create deepfakes.
So I think there's a pretty fast jump from the technology that you just described to the potential for misuse. Can you help me understand the the types or the ways that deepfakes, beyond the obvious that you are already described, the ways deepfakes might be used for things like misinformation or hacking with phishing attacks? What are some of the ways that this technology is being used by cyber criminals and other bad actors?
Right, right. So, like this technology actually, when it was first starting, it was all with good intent. It was to like help us represent our online persona better, like having realistic avatars, having realistic 3D digital twins, etc., 2D, 3D digital twins, etc. But of course, bad actors came into the picture. And maybe the most obvious one is like political misinformation. We have seen some elections being manipulated by politicians saying things that they never said or trying to influence some different populations. Um, there was another area that deepfakes are being unfortunately used is adult content, and there was a report a couple of years ago that was saying that 96% of all the deepfake 95% of all the deepfakes were in adult content, making celebrities or known people or unknown people but wanted people do adult things. um, Another area that is actually coming up, and we have seen some samples of that, is trying to use it in stock market or for banking related operations. And I don't know whether you have seen it, but in Reddit there is like JPOW deepfakes that are saying buy options, sell options, etc. But like it is such a volatile situation, so if you see something like that, you're like, okay, okay, I'm buying, and it's gone already. Um, there are some other like there are many use cases, like like impersonation. People are trying to gain money from likeness of actors. You do a Tom Cruise deepfake that goes viral, and suddenly you are making money from an actor, but that actor didn't hasn't grant you the rights to use his face, etc. So all of those, unfortunately, negative impacts are out there.
So even with generative AI, it was fairly easy to figure out if an image was fake. At least a few months ago, it had problems with hands or generating ears, and you could look for these telltale signals and have an idea if an image was fake or not. But that has changed even if in a few months. The technology is improving rapidly. So tell me a bit about how your deepfake detection technology tracks and finds this kind of broad spectrum of uh, technologies and synthetic personalities.
Right. Yeah. So we at Intel, we released the world's first real-time deepfake detection platform, and currently it uses Fake Catcher as its core. And Fake Catcher is changing how we look at deepfake. So as you just said, looking at the hands or looking at the boundary artifacts, looking at symmetry artifacts, like all of those were some signs that we look for fakery in all those images, artifacts of fakery, right? So we twist that question a little bit, and we are trying to look at what is real, what is authentic in real videos. And heart rate is one of them. So when your heart pumps blood, it goes to your veins, and the veins change color because of the oxygen content. That color change is not visible to our eye. I cannot just look at this video and see your heart rate, but that color change is computationally visible, and it is called photophylic tomography, PPG for short. So we take those PPG signals from many places on the face and we look whether they are the same because you have one heart rate if you are real, right? So we look whether they have this sinusoidal shape. We look whether your heart rate from left cheek and right cheek are the same, etc. So we took those spatial, spectral, and temporal consistencies and create PPG maps from those properties and train a neural network on top of PPG maps to classify them into real and fake videos. And we have a stunning 96% accuracy for fake catcher to find deepfakes.
So it's kind of fascinating. It sounds like you were using something that is inherently human, or at least biological, and using that to test against a an agent or an actor that could be biological or could be a digital facsimile. Um, so I'm curious about the actual implementations of this technology. Is this something that uh, I mean, is there an API that allows you to integrate, or like, is this kind of in the realm of academia and fascinating but hard to scale?
Fake catcher was in the realm of academia. In Intel, we took Fake catcher and we built the real-time platform around it so that it is scalable. We can run up to 72 concurrent detection streams on Intel's Xeon third generation processor, and we can go even more on Sapphire Rapids. I'm not giving performance metrics, but that shows the scalability of the approach. Now, if you look at the implementation, we have different customers and we are trying to go customer by customer. Either we understand their domain, so we provide the best version of the product, or we help them deploy it into their workflows. But the product is released like 2 weeks ago to our first customer, and we are very happy about that. So mainly we have four types of customers. The first type is like social media platforms, as you can imagine, because all those deepfakes are being viral and like spreading from those platforms. The second one is news agencies and broadcasters. They have so much third party material. We want them to actually first whether understand it as a fake or not before actually broadcasting that. And we are working with some agencies for deploying the real time detection into their workflow. The third one is mostly on the content creation. So we have been talking about defect detection a lot, but our trusted media team is working on more things. So detection is one of them. Responsible generative AI is another one, and media provenance is the third one. So all these content creation tools and customers in that domain are using other products from trusted media. And the last one is startups and nonprofits that want to democratize this use of AI to everyone, in the individual journalists and the end users, etc. And we are working with them to provide APIs to everyone to use.
I want to take something that you touched on and expand a little bit. This is obviously emerging technology. Even the detection technology is emerging as AI and deepfake technology is evolving. Um, how do you build ethics policies around that, and who do you work with um, in a non-commercial capacity to help you kind of figure out guide rails or the correct, a good ethical path to put this technology on?
This is definitely a needed question. Thanks for asking that. So, in Intel, Trusted Media is a part of ISR, and Intelligent Systems Research Lab. And we don't only have technologists, we have anthropologists, we have social scientists, we have user research, and all of these different domains, different experts coming together to build those systems. So we are not just looking up and saying that we have this awesome tech, let's just like release it to the world and be happy with that. So we are trying to look at these multi perspective. On top of that, Intel has responsible AI console and like written documents and procedures and um, rigorous review for any AI system to follow responsible AI and ethical AI principles. And in that, again, like it's not just technologists that are looking from there, but we have legal people, we have, again, like social scientists, we have psychologists, and all of them are coming together to um, pinpoint the limitations, document the limitations, find if there's bias, algorithmic bias, systematic bias, data bias, any type of bias, find if there are any possible use cases of a technology that can harm people. And harm is not just like harm in the sense, it might maybe even like confusing people or not really a tool for helping people, you know? So all of these are investigated by the responsible AI console so that any AI approach that are not only just deepfake detection or generation, but any AI approach that is coming from Intel is actually reviewed for being helpful to humans.
Um, what about education, especially when it comes to law enforcement? I can imagine a number of misuses of this technology to manipulate law enforcement and potentially cause great harm to individuals. Do you work with law enforcement or other organizations to help them better understand that this is a real threat or potential threat in the future?
We actually, I actually had a brief collaboration with some legal people back in UCLA when we had this deepfake understanding and action plan, and it was very it was very new at that time. So there was not even any guidance about how legal people should proceed in those cases. I mean, image forgery or video forgery has been a topic for many years. It's not new, but the way that image forgery is created and the photorealism of that and the experts that are looking at those content are really different if you look at the deep generative models and like the new type of synthetic data. Nowadays there are like many other legislations and many other like proposals that are being formed around deepfakes. I think US is still a little bit behind on that topic, but like Europe is much further. But hopefully, we have some contacts both in Intel and outside of Intel, other collaborations that we are trying to first start with awareness, first show that like what is possible with the technology, and then show that defect detection is actually needed and essential for any video processing framework.
So I know that there's actually some cool and legit purposes for deepfake or synthetic personalities, synthetic media. And something you touched on at the very beginning of this conversation kind of reminds me of where a lot of people want to see this technology head, and that's um, these or what we have maybe been experiencing in synthetic personalities or doppelgangers ourselves that live online. Tell me about the legit purposes of deepfake technology, and maybe hint at where the future is going, or where the technology is going in the future.
Sure. Yeah. As I said, like legit users started with avatars and like representing ourselves better in digital environments, and there are also some specific use cases. So, for example, we developed an approach called My Face, My Choice, and that is bringing deepfakes for enhancing privacy in online platforms. So, just in lay terms, we have many online photos, right? Like on social media, our friends are uploading continuously our photos. Do we want to appear in all of them? I don't. Some of them I'm like, that's not me, you know? So we bring that contextual integrity on social media platforms, saying that it is my face, my choice to appear in that photo. If I don't want to appear in that photo, my face is replaced with a quantifiably dissimilar deepfake so that I'm not recognized anymore. The image is there, like without emojis on faces or without masks or blurs. The image is there as a real image, but my face is not there anymore. Thus, my identity is not associated with that photo anymore. And there are many face crawlers on the web, like Clearview AI or like social media platforms storing face embeddings of millions of people, etc. So this is to counteract all that automatic face recognition algorithms, so that we are not there anymore. And the more that we use the system, it is actually exploding the search space of all of these face recognition algorithms, so they cannot differentiate two faces anymore, because instead of looking for 2 billion faces, they will be looking 2 billion times 2 billion faces.
I'm Dan Patterson, and for more interviews like this one, make sure you subscribe to the channel. And for the latest in emerging technology innovation, visit ZDNET.com.